All right, so today we're going to finish up this variation functions. And we're going to look at tables and determine whether those tables represent a direct variation or inverse variation relationship. And so we can see we've got the direct variation and inverse back up here. All right, y equals kx, so k equals y over x. And y equals k over x, so then k equals x times y, things we talked about yesterday. So if we want to find out whether we have direct or inverse variation when we have a table of values, it's very simple. If you multiply and you get the same answers for each one, it's inverse variation. If you divide and get the same answers for each one, it's direct variation. And if neither of those things happens, then it's none of the above. So to identify them, all we're going to do is we're going to do some multiplying and some dividing. We get the same number, we get one or the other. So look at letter A here. We have 3 points. The point 6.58, 13.4, and 104.5. If I multiply or divide all those numbers, do I get the same result? Okay. So you can try, what you want to do is you want to look at them and say, okay, which one makes sense? Or maybe you want to eliminate and say which one doesn't make sense. Okay. In this case, let's look at just the first two. Okay. If I divide here, will I get the same number? Is 8 divided by 6.5 equal to 4 divided by 13? Or 0.5 divided by 104? Okay. Or you can think of it this way. Okay. With inverse variation, or with direct variation, as one gets bigger, the other one gets. With direct variation, when one gets bigger, the other one gets bigger. Okay. With inverse variation, as one gets bigger, the other one gets smaller. Okay. So we want to look at them that way. Okay? So in this case, x is getting bigger, right? What's happening to y? Getting smaller. So I'm going to assume this is probably an inverse variation. So I want to try multiplying them and see if I get the same answer. So I know 13 times 4 is the easy one. That's 52. Half of 104 is 52. And this one's the big question mark. Is 6.5 times 8 52? Okay. All right. So all of those are the same. So then this is a inverse variation relationship because x times y is equal to 52. But the first thing I looked at is, okay, what's happening with x and y to begin with? As x gets bigger, what's happening with y? Is it getting bigger or smaller? Okay. Letter B. What happens with y as x gets bigger here? Because you're writing, I'll wait. All right, so x is getting bigger, y is getting bigger. So I'm thinking, okay, direct variation. So I'm going to divide them. 30 divided by 5, 48 divided by 8, 72 divided by 12. Are those the same? Okay, they all equal 6. So this is a direct variation relationship. So look at the x's, look at the y's. Are they getting bigger or smaller? Compare them. Okay. Letter C. X is 3, 6, and 8. Y is 5, 14, 20. So X's are getting bigger. Y's are getting bigger. So do I get the same answer when I divide? Okay. So they're all different, right? 5/3 is not the same as 14 over 6, which is definitely not the same as 21 over 8. Okay. So since it's neither one of them, then my answer is it's neither. It's not direct or inverse variation. It's just neither of them. And so that would be your answer. Neither. Okay. All right, so let's look at combined variation. All right, we just looked at it. Okay. Basically, combined variation is where we have direct, which is going in the numerator because when X gets bigger, Y gets bigger, and when it's inverse, it goes in the denominator. So here's our formula for direct or for combined variation, where we have something that varies directly and inversely in the same question. How you liking these story problems? They good? No? All right. Okay. Good. The more you get used to them, the more you do them, the better you are. The change in temperature of an aluminum wire, okay, here we go, varies inversely with its mass, okay, and varies directly with the amount of heat energy that's transferred. Okay. So we have varies inversely and varies directly. So when I set this up, what does it say? It says the change in temperature of an aluminum wire varies inversely as a mass and directly. So temperature is measured with the letter I. So we have I equals. It's inversely with mass, so mass goes in the denominator. It's directly with the amount of heat energy, that's E, that goes in the numerator with K. And actually K could be out front. All right, it could be in the middle here with the fraction if you want it to be, but we're going to put it in the numerator. And so this is going to be just like that problem we just did then on number 41 that we were looking at. First thing I got to do is find K. Then they give us a new scenario, and we find that missing part. So it says the temperature of an aluminum wire with a mass of 1/10 rises 5 degrees when 450 joules of heat energy are transferred to it. Okay. So our temperature changes by 5 degrees, okay, because it says it's the change in temperature, with a mass of 1/10 of a kilogram, so that's in the denominator, 0.1, and 450 joules of heat goes in the numerator. So I have to solve for K. So let's see, I have two choices. I can divide 450 by 0.1 first, or I can multiply both sides by 0.1 first. It doesn't matter, okay? Whichever one you want. I'm going to multiply by 0.1, so we get 0.5 equals 450K. So then when I divide by 450, we get K equals some very large number, right? 0.001. Oh, okay. Or a smaller number. 0.001. Okay. So then we go to scenario 2. How much heat energy must be transferred to an aluminum wire with a mass of 0.2 of a kilogram, raise its temperature 20 degrees? So I is now 20. We know K is 0.001. and they tell us the mass that goes in the denominator. Oops, not K. That would be E. All right, so we're solving for E. Let's see, I'll multiply by 2/10, and I get 0.4, or not 0.4, 4. 4 equals 0.001 E. We divide by 0.001, and so we get 4,000, right? Okay, 4,000 what? Joules. Joules of energy. All right, any questions on them? Okay, good. Quick factoring reminders. So I'm going to do 2 of these on here just to remind you how to do this. All right, so we got number 1, x squared plus 7x plus 10, and they want us to factor this. So what are we looking for? Okay, so we want the factors of c, right? This is x squared plus bx plus c. The factors of c that add up to b, right? Okay, so what are the factors of 10 that add up to 7?
5.
Okay, 2 and 5. So then that means we're going to have x plus 2 and x plus 5. Does the order matter for the plus 2 and the plus 5? No. Okay, it can be either way. All right, so that was number 1. And then let's look at 21. X squared minus 7x minus 30. Okay. So if you have to, you can write these down, okay? Factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Okay. Now, in this case, if this is a minus here, that means that one of them's got to be positive, one of them's got to be negative. And it's really easy to determine which one it is that the bigger number, okay, the bigger number is always going to be the sign of B. All right? So I'm going to subtract these. When I subtract these, which one gives me 7? 3 and 10, right? Okay. So since the 7 is negative, then the 10 is going to be negative. Okay. All right, good with that?